All right, welcome friends, sanguine and synthetic. There will be no I am not a robot checkbox to access this presentation. A long time ago in a conference far, far away, I've gripped it and it was in Sydney during the year of Our Lady Gaga 2017, which feels like a different century in a different galaxy. I first speculated about where our yearning for artificial intelligence, which predates information technology itself, would end up. If it fails, we don't get artificial intelligence, we're going to have to get by with non-intelligent machines. If it succeeds to any degree, where do we draw the line between software and slavery? How long until our successors look back at those I'm not a robot checkboxes as if they were segregated water fountains? Looking back to 2017, this was about 9 months before the first of the OpenAI generative pre-trained transformers, GPT-1, landed on the scene, but it was a few months after the first papers about the concept. So those first few falling pebbles entirely escaped my notice at the time, and I remain only mildly informed about the state of the art in so-called AI. The only thing I can tell you for sure is that it's blue. So as a non-expert, I'm going to refrain from broadcasting my opinions too much. I've heard that's a thing you can do. But what I do have some expertise in is how much computing you can cram into a tuna can after you remove the tuna. So what I want to explore today is what kind of things we can do in the realm of self-contained, non-intelligent appliances. Now, there was a series of movies and books almost a generation ago about a secret world of magic, which we all know is just sufficiently advanced technology. This technology was mediated by wands and pocket maps and magic cloaks, wearable computing. This fantasy world did not appear to ever explain how a two-word invocation could result in repairing a broken pair of spectacles or washing, drying and storing an entire sink load of dishes. Surely you'd at least need to supply the lens prescription or specify that the good silverware goes in the sideboard, not the kitchen drawer. But it turned out that whole society ran on slavery and the author was practically a Nazi. This is why we can't have nice things. That other crypto-fascist magical franchise, Star Wars, seems to pay a bit more attention to credible user interfaces. In order to individually levitate 100 chunks of rock and rescue your buried friends, one has to at least adopt a determined expression and arch your hand just so. Gesture-based computing, in fact. I gather that Apple is right on top of refining this at present, and I'm sure Aaron Quigley and his gang of co-conspirators from the keynote would love to get some force chips into their prototypes. But of course, as soon as you look at the interactive technology in Star Wars, you see once again that the whole ecosystem runs on slaves. But there is one thing that Star Wars got right. There are always two, the master and the apprentice. The apprentice model found in fields such as motor mechanics, plumbing, pair programming, brain surgery, and yes, galactic intrigue. The apprentice is there to pass tools and learn how to anticipate the next tool on the way to becoming a master themselves. And as someone who works alone at the moment, having had a series of interns back in the before times, and being the possessor of a factory second brain and a collection of increasingly creaky joints, I really would appreciate having an apprentice again. I'd settle for a mystic energy field that binds the universe together, even between me and that screwdriver. A magic wand would be great as well, but as I've said, they are, and I'm careful to remain PG here, a load of horsepucky. Switching franchises again, Iron Man has his Scutters and Jarvis to locate and supply the right tool or put out that fire, and props to Iron Man for freeing his slaves eventually. Amazon promised the same magic infrastructure with their supermarkets where you shovel items into your shopping cart and the store computer adds it up. If you didn't hear the story, about a week or two ago it emerged that this whole chain of no checkout stores actually ran on offshore wage slaves glued to video feeds. The other big attempt at household magic, of course, was the home voice assistants, Amazon's Alexa, Google's Home, Apple's Siri, and the rest. I'm really disappointed in these. They're utterly reliant on fast access to the cloud, and their business model is basically privacy violation. It's pretty clear that Google and Amazon have worked out that there's no money to be made here. Apple has had some great ideas, but they don't appear to be putting in the effort to carry them forward. So maybe the whole concept of voice interfaces is over and done. It'll never work. In one universe, this presentation ends here. Thanks for coming. But what is it that I want anyway? Right now, every company and their dog is adding generative AI chatbots to their products. Microsoft is going all in at the operating system level and also in their development platforms like VS Code and in GitHub. Google's betting the farm on Evil Empire, and a big part of that is something that Jeff Houston mentioned in his keynote on Tuesday. He called out DoubleClick in his history of where the internet went wrong, the panopticon advertising company that wants to know everything about you. Whatever happened to DoubleClick? Well, Google bought them in 2008, and then DoubleClick hollowed out the soul of Google and now wears the corpse around like a false mustache. Amazon's approach with the Alexa ecosystem was skills. The idea was that developers would write voice control modules along with their product firmware. Amazon would give you free hostings and incentives to develop skills. And until last week, when they pulled the plug on that whole program, it seems that Amazon is planning to pivot to generative AI along with everybody else. You can ask Apple Siri things like, "Where is Jane?" or "Remind me to book the car in for service when I get to work," or "Dim the lights in the TV room." This is exactly right, but it's still pretty limited. I think it could be great if the missing pieces get built, but that doesn't seem to be a priority. Instead, the rumours say that the next update of the iPhone OS is going to be focusing on generative AI too. And it would be great if those things worked, but like the border between software and slave, there's an extremely fuzzy and hard to detect border between a useful expert system and a pack of lies. In another universe, just one more revision to ChatGPT finally solves the problem of hallucinations. We all get a pony, and this presentation ends here. Thanks for coming. Despite the fact that venture capital is showering the field with money, OpenAI is promising to spend something like $1 trillion on development, and every major vendor is going berserk, stenciling AI onto their product boxes. I think it's a con, and I think the investors and the vendors also know and think it's a con. I know I wouldn't spout my uninformed opinions about AI, but it turns out there's a real fuzzy boundary between my promises and lies too. In one universe, maybe this one, AI mania runs out of money, the servers consuming vast amounts of energy and water go dark, and conversational interfaces acquire a stink that lasts a generation. Presentation over, thanks for coming. But it's not all doom. Well, maybe it is all doom. Doom the Game from 1993. Not the first 3D game, but the one that everyone remembers. And within a few years, if you wanted to enjoy 3D games, you bought yourself a graphics accelerator. And a few years after that, you needed a graphics accelerator or a GPU to play new games. And that feedback loop between games and GPUs led to these things becoming massively powerful vector processing supercomputers, which enabled other clever applications like face recognition and protein folding, and also stupid applications like blockchain and generative AI models. Oops, another opinion, sorry. But now that we proved that these novel vector applications are possible on the hardware, and if you dream big enough, people began to dream small, and we start getting vector acceleration hardware in phones and smartwatches and microcontrollers. And that's what I think the generative AI boosters are betting on, that before they run out of money running these massive uneconomical server farms, that commodity hardware will catch up and they can run your scams on your computer instead of theirs. And that's what I'm going to do too. So here's my evil plan. We've just reached a point where this year's phones are going to be doing speech recognition on the device rather than having to transmit audio to the cloud. We might get one more generation of home voice assistants that acquire this capability too before the money runs out. And right now we can buy small form factor computers and even microcontrollers that have the so-called AI acceleration hardware that allows some form of voice recognition right on the device without needing any cloud service. So finally, we have the potential to roll our own conversational interfaces without the cost, latency and creep factor of cloud services. But like all my evil plans, unfortunately I'm running late and a whole lot of other folks have gotten part way to world domination already, and we'll go through that first. But before then, I want to step back and look at some key concepts that you're going to need to recognise to understand the rest of this presentation. So, in order to understand how to do all this stuff, we're going to have to break it up into steps. And that makes total sense in the open source world because many of these steps resolve to single software projects. And in most cases, there's a number of projects that you can choose from to perform a particular step. Sometimes all this software runs on one system, sometimes it might be spread across systems. And that's what gives us flexibility because we can arrange the software to fit the kind of tasks that we want to do. Now, I contrast that with the big three voice interfaces, where the same steps exist, but there's no choice about how those pieces fit together. So, the first thing that needs to happen is that we need to get the system's attention. This could involve pushing a button or moving a device. An Apple Watch will start listening when you lift it to your mouth. Most of the time, we use what's called a wakeword to activate the system. This is a privacy and efficiency trade-off to some extent. You don't want to accidentally trigger effects due to snippets of normal conversation. And in the older systems, you don't want them having to record everything you say and upload it for processing. So this was the first piece of the puzzle that got implemented on device. Alexa, OK Google, Hey Siri. Those are the phrases that the big three default to. And the dirty secret was that those phrases were chosen to be easy to recognise. 3 or 4 regular syllables. Alexa, Hey Siri. Mostly ending in a vowel, because false triggers are really common, because those models are quite loose. It's less annoying to a user to have it try to listen to you more often than you want, rather than less often than you want. But the part that squicks most people out about the cloud, for example, there's a big story in the news a couple of years ago about how a couple who were having a screaming domestic argument and their voice appliance somehow hallucinated some of the words that they'd shouted to be an instruction to compose a text message to the co-worker who thought that his friends were murdering each other. So when I started considering this subject, wakeword recognisers were expensive and difficult to produce. You needed hundreds of hours of audio recording and weeks of compute time to train a model. I actually considered 6 months or so ago picking some new wake words and asking the attendees at this event to donate a few minutes of their time to record some performances of those words so that I could engage a cloud service to train me a model. But in the last few months, the state of the art has moved on to the point where an open source wakeword model that can run on a device like this can be trained in about an hour. So once the system knows to start listening, it has to produce that waveform produced by the humans squirting air through their meat into symbols. That's called speech recognition. Now, pretty much every system out there breaks this out into a speech-to-text step. That is, it converts audio to ASCII and then interprets the ASCII. A particular AI model that can recognise speech will only work for a particular human language. But there are some recent advances about detecting which language a person appears to be speaking and activating the model for that language. Now, you don't strictly have to do voice recognition. The alternative is called word recognition. Instead of converting the speech to text and then having a separate step to understand the text, simpler systems simply have a list of phrases that they're expecting to hear, and they perform that much simpler task of determining that this audio sample matches phrase 7 or phrase 12 or none of the above. That's obviously less flexible, but it's also something that can be done on a very small microcontroller. And I'm going to come back to that in large detail near the end. But back to voice recognition. We have a phrase that we've converted to text. Now we want to know what to do about it. This is called intent recognition. And this is the big task that those commercial voice assistants almost entirely consist of. Google, Apple, Amazon, they all have big systems that direct voice commands to various of their other products, their movie players, their home automation, their apps on your phone, or the marketplace of voice services that they expected vendors to create, but which didn't really happen. And in the open source world, there are a number of projects that do that, and I'm going to talk about some of those soon. But let's finish the picture first. Processing an intent could be a fire and forget operation. Something like turn on the light is a complete conversation in itself. More complex operations like composing a text message or scheduling an appointment might involve a bit of back and forth. So some systems require a conversation management component to handle these complex interactions, and Apple is particularly good at this. And if you have an Apple device and you haven't played with their shortcut system, which allows you to basically generate entire programs that act on voice prompts, it's really quite impressive. But when an intent resolves to an action, then there needs to be some communication with the outside world. A message goes to a light switch, or information passes to an app on your phone, or it might go into a message broker where a number of consumers could act on it. And then finally there's feedback, answering, okay, I've opened the pod bay doors, or I'm sorry, Dave, I can't do that. Here we've got a text-to-speech conversion system. And this is something that's always been, to some degree, feasible on a small device. Even back in the 1980s, there was basic speech synthesis that would run on a home computer like a Commodore 64, but with considerable variation in quality. Quite a number of the commercial systems still do the text-to-speech conversion in the cloud, but on the other hand, on-device text-to-speech I think is finally good enough that I expect the use of the cloud for this component to decline. All right, so now we're ready to start looking at some actual software projects that you can run on a small Linux device or similar. I'm going to go bottom up. That is, we'll talk about the low-level operations that deal with audio, and then we'll consider the intents and the conversation handling later. So let's start with wake words. I'm not even going to waste your time with anything that hands audio off to the cloud here. All the things I'm going to talk about here run on Linux, but most of it will run on BSD or Mac or that other operating system also. Snips.ai used to be a popular website, but it got bought out and shut down. Pico Voice is a very portable system that runs on a bunch of processors, supports like 16 different languages. Their open source library is called Porcupine, and it's on GitHub under an Apache license. I think a license fee is required for commercial use, so if you are experimenting with it, do look into that. And if you want to train your own wake word, they have a website that will walk you through the process, but they do give you a few default wake words out of the box. And this project has got integrations to a ton of programming languages, so if you're keen to work in your pet programming language like Rust or one of the other newer systems, this is probably the project for you. However, the training engine that creates those wake words is not open source, so that may affect your decision. You need to take your audio to them to produce a wake word. I first got interested in voice interfaces when I saw Kathy Reed, who's a regular at these events, talk about them in, I think it was Christchurch in 2020 or 2019. At the time she was working for Mycroft.ai, which is no more, but yay open source, because the code that they produced is still out there, the community still exists under a new name, and in this case their training engine is open source too. It's an older code base, but it checks out. So if you want to train your own wake word, that's a totally feasible option. The other old-time, totally free option is CMU's Pocket Sphinx. It's still being developed pretty much in life support mode, but even the authors admit that it's probably time for you to consider going somewhere else. The new kid on the block in the last 6 months is Open Wakeword. Again, you'll find it on GitHub. And even if you don't end up using it, its README has a really good explanation of its goals, the landscape of voice recognition, and which other projects might do better in some areas, which I love, love, love. Open Wakeword trains its models on synthetic speech, so you don't even have to record human speakers. That sounds like black magic, and I would be very suspicious, except for that README file, which is so open about all the other options in the space and how they compare. So if you check out one wakeword project, make it open wakeword, and it will lead you to the others. So that's wakewords. The next step is that speech to text. And again, there are so many cloud-based speech to text engines that I'm not even going to talk about them. The offline speech recognition engine that's leading the pack right now appears to be OpenAI Whisker. Now, OpenAI is the company behind ChatGPT, and they have internal politics about whether artificial intelligence is going to turn us all into matrix victims in a box. So consider whether that might sour you on having anything to do with them, but plenty of people are using the project happily. In the speech-to-text space, we've got Pocket Sphinx again. It does both wake words and general speech processing. Very free, speaks lots of languages. Again, getting on a bit. Another project that comes out of academia is called Caldi. It's still getting developed. It's got really good doco. You can tell it comes from academia because it's not flashy, but it definitely seems to do the job. Another option is deep speech, which came from Mozilla. Now, Mozilla was getting heavily into IoT 4 or 5 years ago, went really big on home automation, and then shut the whole thing down and abandoned it about 2 years ago. And I think this particular project hasn't had a release in 4 years, but it works. And one thing that distinguishes is it works with graphics accelerator cards. So if you've got a PC with a GPU, then this will give you a performance and accuracy boost that might put it ahead of the other options. Let's skip over intents and conversations for the moment and look at text to speech. This is another area, again, where the bleeding edge of quality is cloud-based, but the on-device options are good enough for me. I'm just going to refer you to this webpage here to run down the pros and cons of various offerings. Raspy is an open source project that does the whole voice assistant ecosystem, but again, being a model open source project, their documentation is quite happy to link to the other options in the space. If you're generating English, the TLDR is that you've got lots of good choices. And if you want to generate speech in lots of languages, then you've only got a couple of choices, and the quality is pretty ordinary, but the options are there. The one from that list and other places that stands out to me is called Piper, which is what the Home Assistant project uses. It does support a lot of languages, and it's got a choice of voices in many languages. So, for example, in English, you've got a handful of American male and female voices. You've got English regional, you've got sort of Central English, you've got Southern English, you've got Scottish, you've got Irish. So if you're very particular about the kinds of personality you want to imply with your voice output, it's well worth a look, and it is being actively developed. Now, let's talk briefly about hardware. Pretty much everybody starts out with a Raspberry Pi single board computer. I've got more of them lying about than I know what to do with, so that's what I'm using too. These things notionally cost £20 UK. In practice here in Australia, you're looking at $70 to $100. And if you're starting from scratch, I would say get the Model 4 or the Model 5 with as much RAM as you can. They come in, I think, 2, 4, 8 gigabytes of RAM. The old version 3 tops out at 1 gig. So I would say if you've got one lying around, give it a shot. But if you're going to buy one, the 3 is obsolete. But one interesting thing about that Pi 5, which is brand new in the last 6 months or so, is it's got a PCIe slot into which you can put a processor board like the Google Coral, which is a little thing about yay big, costs about $30, that is essentially a GPU. Again, so you get the hardware acceleration. On the other hand, if you have a small laptop or a Intel-based small form factor PC, you could use that. I swore a long time ago that I would never buy another desktop PC, and I've been surviving on dumpster diving and hand-me-downs for my desktop needs. But even so, you can dumpster dive GPUs these days. And finally, there's a number of off-brand Raspberry Pi workalites. I've been using this Radza Zero, which I talked about in my wearable computing talk, I think that was last year. 4 gig of RAM, 128 gig of onboard flash, quad processor, SD card socket. I think you can now get 16 gig of RAM in this form factor. And the good thing about this factor, is you can get these microphone boards, which have an array of between 2 and 6 microphones on them, because the more microphones you have, the better you are at suppressing background noise and coping with noisy environments. So yes, it's possible just to plug in a USB microphone and run with that. But if you want to get the best performance in a noisy environment, then a multiple microphone array is cheap and easy to get working. And my notes at this point say breathe, so I'm going to breathe. The concept of doing audio processing on a microcontroller, and when I say microcontroller, I mean a chip that postage stamp sized, not a PC, can't run an operating system like Linux, further down the food chain, simpler jobs, but still fantastically powerful compared to the supercomputers of the 1980s, for example. And the architecture that pretty much everybody uses here is the ESP32 from a company called Espressif. We're talking about a couple of CPU cores at maybe 200 megahertz each, a handful of megabytes each of flash and RAM, for as little as $5. Espressif are in the middle of migrating from their S series, which are Tensilica-based CPU cores, to their new C series, which are RISC-V cores, which is the new open source instruction architecture. So not only is the software open source, the CPU can be open source. But I'm going to stick to talking about the S series here, although I am a big fan of those C series chips. It's these S series ones which have the AI accelerators built into the chip. The original ESP32, sometimes called the S1 now, is not a slouch, and if you've got some lying around, use them. But again, if you're shopping for something new, the model you want to look for is the ESP32S3. That's the latest model in the S series, and it's the one with all the hardware acceleration goodness. Now, for a bare bones job, all you need is a development board. This is an evaluation board that comes from the manufacturer. I think it cost somewhere around $50. It's got 6 microphones on top. It's got a bunch of lights. It's got SD card if you want to deal with multiple languages or have lots of wakeword models. You can load them up off the memory card. And there are models, increasingly, many of them hitting the market in the last few months that have got an LCD screen in them too. And your hardware choice is going to depend on what your application is. If you're doing home automation or conversational interfaces and you really want to replace the idea of the Amazon Echo or the Apple HomePod or the Google Home, then you'll probably find that you're going to want to end up with something that looks much like them. You know? It's a puck with a bunch of microphones around the outside. In that case, your ESP device is going to do the wakeword processing. And then if you're using a conversational interface, you're probably going to be streaming the audio, not to the cloud, but to your Raspberry Pi or your PC or an old laptop or something in your home. The other use case, and the one that I'm most interested in, is building direct voice into an appliance where the microcontroller is running the appliance and it also just happens to have enough power left over to add a voice interface. And if you think about off-the-shelf Internet of Things gadgets like light bulbs and motorised blinds and what have you, they just take orders from an intent processor, which might be your voice assistant base station or it might be in the cloud. But that means that they only work as part of a network of home appliances. You don't take your light bulb for a walk. Most people don't take their light bulb for a walk. My application is for tools that I can take with me, either body worn. This is actually designed to clip on to a glove or an arm, and be able to shout at them without needing that support network of the rest of the home automation system. Now, as far as I know, we do not yet have a general speech-to-text system that can run on these microcontrollers. But I am willing to be surprised, given that the number of things that have surprised me in the last half a year. But there are a number of options for phrase recognition. There's a couple of different systems that work with Google's TensorFlow Lite and will run on embedded processors from ARM and from Espressif and Otherworld. Espressif ship their own voice toolkit. It's called ESP-SKINet that runs on these processors here. It does its own wakeword detection. Again, if you want to train a new wakeword, you have to fill a briefcase full of audio recordings and another one full of dollars and go and see them. But it works in English and Chinese, and the phrase recognition component of it is, as best I can tell from my experiments, really damn good. But it can only recognise up to 200 phrases from a list. And you specify that either as English text or Chinese text or as phonetic voodoo symbols if you happen to understand those. And if it thinks it's recognised one of those 200 phrases, it'll give you a confidence level. I'm 92% sure you said turn on the light. Or I'm 17% sure you said launch the missiles. So maybe you don't want to do that. But I have found it to be pretty accurate. But the cool thing is you can load up different phrase tables at runtime. So you're not actually limited to those 200 phrases. You're only trying to match the phrase that makes sense in context. And I'll give some detailed case studies of that a bit later. But in the case of these dedicated devices, I don't even bother with wake words. Right? If I've got a heat gun or a soldering iron or a microscope and I want it to do something, it starts listening when I switch it on or when I pick it up. And if I haven't spoken to it in a while, it'll shut itself off. It doesn't have to listen for a wake word. It can listen for those phrases on the device. Doesn't cost any network. Only costs a little bit of CPU. Maybe it runs the battery down a bit more than normal. But it is very flexible. And just going back to wake words, if you don't want to go the route of Espressifs, there is yet another new brand, shiny new open source project on the block called Micro Wakeword. Again, you'll find it on GitHub. And that also uses that synthetic speech hack where it speech synthesizes 100,000 different variant pronunciations of Jeeves or whatever your wake word is, and trains a model. Can do it all yourself at home. So, before I get to my own favourite application, which is these voice-activated appliances, I do want to backfill the last piece of the missing piece of the puzzle, which is home automation. But right now, the big commercial systems, Amazon, Google, Apple, they're all sending audio recordings to the cloud. Now, maybe that works in Silicon Valley, but it's not great in Gladstone. But I predict that will change. All the rumours say that the next version of the iPhone is going to do all the voice recognition on device, and I'll be surprised if I don't see that across the board within a year. Now, in the open source world, there is a number of really great home automation systems. I built my own, which I pretty comprehensively regret, but at the time, there really wasn't a clear winner across the board that did what I needed. But that's changed. I think that Home Assistant is the one to beat at the moment. And for them, They declared 2023 to be the year of voice, and they focused on that for over a year. And they built an intent system and an ecosystem of interfaces to devices and other platforms. There are some other systems that you might consider if you have special need. That one, Raspy, that I spoke of before, that's RHASSPY. The remarkable thing about that is it all works via a message broker. So if you're already into MQTT and you're passing stuff around, then that might be the system for you. There's also one called Calliope, which has got a very impressive website, and it clearly set out to prioritise building an ecosystem of triggers and effects. But it seems like maybe the wind's gone out of the sails and it's been pretty idle for the last couple of years. But the other thing that makes Home Assistant compelling is that you can run it on your PC or your Raspberry Pi, but then you can cite a bunch of really cheap, low-spec devices around the house to be your listening agents, and they will forward the voice to the big system to manage it there. For a while there, everybody was building an open source home automation system, Mozilla and Microsoft and many more, but I think it's pretty clear that Home Assistant is going to be the crocodile to all those dinosaurs. And Home Assistant also plays well with your gear from Google and Apple and Amazon, so that's really quite good. All right, so I told you all that stuff to tell you this stuff. There's a famous scene in the 1982 science fiction movie Blade Runner where the detective is improbably enhancing a photograph using a voice interface. The character Deckard says things like enhance 34 to 46, go right, stop, track 35 left, and ends with give me a hard copy right there. I've spent years thinking about that scene. It's an utterly rubbish user interface compared to pinch zooming on a touchscreen or even clicking and dragging with a mouse. But, there are moments where my hands are full and I need exactly this interface. When I'm working with a microscope, I might have a soldering iron or a scalpel in one hand, and at high enough magnification, trying to move the object I'm working on is just a non-starter. So I built a robotic stage, motorised, to move the object around. But again, I've got to now then put down my scroll, reach over, pick up the mouse, tell it to go left. It's not uncommon for a video microscope system to lay a grid on the screen to help you refer to items. And that's what seems to be happening in Blade Runner, is that they're naming the intersections of those grid points to command image actions. And the way I use my video microscope is I plug it into a PC and I bring up the video feed in a window and I bring up my documentation in a window. So I've already got all the pieces I need to add voice here. And this, in the zooming in direction, most video microscopes are quite difficult to work with because you've got 2 or maybe 3 knobs you have to turn to zoom in, but I cheated. The camera that I'm using is really quite high resolution, and I normally in fact scale it down to work with it because it's just too big. So we start out with a big image, and then when we want to zoom in, we just crop the image. So if we overlay a grid and we number each grid intersection, then that rather confusing scene from Blade Runner suddenly makes sense. When Deckard says enhance 34 to 46, he's naming the corners of a rectangle that the system is going to zoom in on. So let's turn that around and look at it from the perspective of a microcontroller. It's limited to 200 phrases. Oh, and it can't even recognise numbers, only the words for the numbers. So we've got 200 phrases to work with. We can start out with go left, go right, go up, go down, stop, give me a hard copy right there. Who's got a printer? Then we've got maybe 180 phrases left over to do enhancing. So for every pair of numbers, we would have to burn a slot. One slot for enhance 34 to 46, another slot for enhance 34 to 47, and so on. Except that some pairs don't make sense because they're collinear. They don't, in fact, draw out a rectangle. So if we lay down a 5x5 grid, we might have to listen for enhance 1 to 7, and enhance 1 to 13, and enhance 1 to 20, but we don't need the other combinations that start from 1. Another way to do it would be to make it conversational. We just listen for enhance, and then we load up a phrase table that just contains the numbers 1 to 80, and we listen for 2 matches. We can ignore the word to in between. Oh shit, no we can't, because the numeral TWO sounds just like the preposition TO. So maybe we start the numbering from 13 to get rid of all those short, difficult to recognise words. Much like how Alexa and Hey Siri and Hey Google needed to pad up the syllable count with that hey in the front. All right, home stretch. What other tools can benefit from video interfaces? Well, multimeters for one. You've got 2 probes that you're holding in each hand, and usually you've got a dial that you have to turn to change what the meter measures. It can measure voltage and current and resistance and continuity and sometimes half another dozen other quantities. So being able to say select resistance, select voltage, hold reading, clear hold and so forth is really handy. Now I already own a multimeter that's got a Bluetooth control API, and our ESP32 here has got Bluetooth. So this is entirely doable. Same goes for oscilloscopes. Most of these have got a USB port or an Ethernet port on them, so you can drop a voice interface on those to save having to twiddle. There are another job where there just aren't enough hands, and then soldering is the big one for me. You might have a wire and a soldering iron and some solder, and you're already well and truly out of hands, and now you need to change the temperature. You can get soldering irons that have foot pedals which auto-feed the solder, and solder paste dispensers which do the same thing, and spot welders that do the same things, but I don't like foot pedals, they don't work for me. I keep losing the little blighters, and eventually you get a cramp. So I stole an idea from another sci-fi author, Neil Stephenson. In his book, The Diamond Age, we see a street thug get a head-controlled gun, and that's exactly what I want to be able to tell my soldering iron. I want to be able to tell it, dispense 5 millimeters of solder, hut, and have it do it. Hit me, another shot. These devices really exist, except that right now they'll use boring knobs and foot pedals until I'm done. One last example, the magic wand I started talking about. Our own unexpected maker from Melbourne sells an ESP32 board that is 11 millimeters wide, so I could fit it inside a wand if I wanted to, or a magnifying visor, or even just a flashlight. But I'll have to think up some spells that don't come from the Nazi wizard. So that's what I have for you, and I invite you to think about what spells you would cast. Thank you.
Thank you, Christopher.